All right, guys, we're going to go through this homework assignment, the 2.3 measures of central tendencies. Um, Basically, we're going to go through the evens today, odds tomorrow. Hopefully, we make it through all the evens within this 47-minute time period. I didn't realize how long this homework assignment is, but whatever, it's 30 questions, so should be all right. Some quantitative data sets do not have medians. That is false. No, I don't want to load it. No. All right, I think I got rid of all that stuff that was trying to load. Um, so number two, some quantitative data sets do not have medians. That is false. That's because we can always put quantitative data sets in order. And if we put it in order, then there's a middle number. Number four, when each data class has the same frequency, the distribution is symmetric. That is true. Because what you would end up with is a data set that looks like this, where those blocks are all exactly the same height. I mean, it's obviously not going to have wiggles in it and stuff, but where the blocks are all the same height, which creates a symmetric distribution. Constructing data sets. Constructed data, the described data set, the entries in the data set cannot all be the same. So the mean and the mode are the same. That could be like 1, 1, 2, 2, 2, 3, 3. Now, if we added these all together, that will give us so 2, 4, 6, 8. 8 and 6 is 14. 14 divided by 7 is 2, which gives us the mean of 2. And the mode is there's 3 2's, so that would be your mode. Number 8, mean, median, and mode are all the same. We could actually use the same exact data set. 1, 1, 2, 2, 2, and 3, 3. Mode is 2 because there's 3 of those and only 2 of the other ones. Your mean is, as we discussed in the last one, 2. And then the median is the middle number, which is 2. Number 10. Determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, skewed left, skewed right, or none of these. Justify your answer. Okay, so for this one, it's pretty close to symmetric. The reason it's close to symmetric is because you have your high points and your lower points on the sides. So your high point is in the middle. If we flip this over, actually just like spun the whole graph, it would look pretty close to the same thing. So that one would be symmetric. Number 12. Now this one always used to screw me up because you can see it builds up and gets higher. And so it seems like it's skewed to the right, but that's actually called skew left. And the lower ones are on the left-hand side. So remember, if it's skew left, then the lower are on the left. Skew right, the lower are going to be on the right. Number 14, frequency distribution of salaries at a company where a few executives make much higher salaries than the majority of the employees. So match the distribution with one of the graphs in exercises 9 through 12. So salaries at a company where a few executives make much higher salaries than the majority of the employees, that would be like number 9. Because we have a couple people making a lot of money and then everyone else makes much less. Okay. Number 16, the frequency distribution of weights for a sample of 7th grade boys. That would probably be like number 11. You're going to have some boys that weigh a little more, but generally they all fall within the same range. Yeah, we do that. Number 18. I'm going to find the mean, median, and mode in number 18. It says if any measure cannot be found or does not represent the center of the data, explain why. Okay, so for mean, you know what we have to do? We have to add these all together and divide by the number of numbers. So there are 7 numbers. So we have 174, 172, 169, 176, 169, 170, and 175. Okay, so I showed you last time how to put that in the calculator under stat. You put it all in the calculator under stat, you get that the mean is 172.1. Then the mode is going to be 169. And the median, or your middle number, is going to be 172. If we put these in order from least to greatest, you would have 169, 169. You're looking for the fourth number. So it'd be 169, 169. Then 170. Fourth number would be 172. Okay, so all this data seems like it falls pretty close to the center. The only one that would bother me would be the mode because it's the 2 beginning numbers. Even then, the data set is so close together, it doesn't really matter that much. It's not like the mode is an outlier. All right, number 20. We add all these together, divide by the number of numbers. You get the mean to be 46. Then the mode is 43, because that's the only number that repeats. And then lastly is the median. Which we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So the median is going to be the 5th number from the bottom. So 36, 40, 38. There's the first 3. 43 and 43. So your median is 43. Number 22, add them all up, divide by the number of numbers. There are 10 people. So our mean equals 200.4. The mode, so which one repeats? None of them repeat, so there's no mode. You could also just do this. I'm fine with that. Okay, and then the last one is the median. So in this case, because there's an even number, we're going to start with the bottom, It's going to be between the fifth and sixth number. So we can get rid of 154, 171, 173, 181. This is going to be between 184 and 188. Which means we add those two together and divide by 2. So that would give you 186. I forgot to discuss in the last ones whether it fit the data. The median mode and number 20 and the mean basically all fit the data. Same with number 22. The mean is 200.4. It's right in the middle of that data. There's no mode, but the median is also in the middle of that data, kind of. The one outlier that would be dragging the mean up a bit is the 275. All right, number 24. The mean for this one is 61.15. The mode for this one, I don't think any numbers repeat. Oh yeah, 80 does. So your mode is 80. Then your median is going to be the middle value, which is going to be 55. Okay, so for this data set, our mean, median, and mode seem to be all over the place. So I don't think the mode is a good representation because it just happens to be that it happened twice. But it still falls in the middle of the data. It's not like they're both at 12 or both at 125. The mean is a fairly decent representation. I would have a tendency to throw a couple numbers out. I would throw the 125. Oh, I just noticed that we did have, it's bimodal. It's 80 and 125. So this one is bimodal. This second mode would not be a very good measure of central tendency because the 125 is a little high. With that being said, then I would not throw the 125 out, but I would throw this 12 out. 12 seems to be a little low as we're looking at the rest of the data set. Even then, not terrible. This is kind of open for interpretation for these ones as to whether you would throw numbers out or whether an outlier is truly affecting it. It's not like any of the outliers or lowest and highest numbers are exceptionally high or low. I think the example that we did in the last lesson with the college class, where you had like the 166-year-old person in there, that makes a huge difference as opposed to things like this, where it's 125, but you have a 103. So, wouldn't worry about it too much. Number 26, our mean, or X bar, is 14.04. Our median is 14.25. Again, this was an even number of patients, so you had to find the two middle values and add them together and divide by 2. And then our mode in this one, I don't believe there is a mode. Right, no mode. Let's look at the X-bar and the median. They're pretty close together. I would say it's a good representation. Number 28. The responses of a sample of 1,177 young adults who were asked what surprised them the most as they began to live on their own. Amount of first salary, trying to find a job. I don't know exactly what we're asking for here. Let's go back and look. Oh. I think I might be missing some instructions. Let me have a look here. Okay. So this is the same set of instructions. If we look at for what the median is just going to be our middle number here. So we can kick out our lowest and highest. And so you get the median would be 150 or paying bills. Okay. Now, would it make sense to find a mean in this case? No, the mean is just going to be whatever the middle number is. It's not going to tell us any information that we don't, or any relevant information to this. If we look for a mode, if there was a mode, it might tell us the two different things that people are worried about most. But in general, if we're just looking at the median is going to be the middle data for what people seem to find to be the biggest issue. So it doesn't make sense to find a mean or a mode here. Number 30. The pie chart at the left shows the responses of a sample of 614 small business owners who were asked about their presence on Facebook. Okay. Once again, if we find a mean here, so if we were to find a mean here, that would be just adding together the values. Same as we've been doing. This would be 258 plus 184 plus 141 plus 31. Divide that by 4. That gives you 153.5. All right, the median is your middle number. In this case, there's only 4 groupings, so you have to do 184 plus 141. Divide that by 2. You get 162.5, and there's no mode for this one. So pretty straightforward, not a big deal. It asks you which one would make the most sense. It would probably be the median, because that would be the center number of people and how they are handling Facebook or whatever. All right, number 32. This one is nice because it's in a stem and leaf plot. At the same time, it means that you have to know how to interpret the data. So whenever you enter the data into your calculator, and I think most of you know how to do this, the first one would be 8, then 15, 16, 18, 21, 23, 24, and 25. And 30 and 39. And 240s. Okay, first, finding the median. Median is just going to be your middle number, so it's nice when you do a stem and leaf because you can cross out. This is going to be 23.5 for your median. Your mode is the number that repeats, which in this case is 40. And then your mean is just adding them all up and dividing, and that'll give you 24.9. All right, not too bad. Number 34, this is a dot plot, which tells us different values. So once again, got to be able to read it, and I think you're all capable of it. First number is 170, then 180, 190, 200 twice, 210 5 times, and 224 times. And then lastly, 241s. Stat calc, one var stats. Your mean would be 207.3. Your median is 210. And your mode is 210. So those are all pretty close together, showing off exactly what you need. All right. Graphical analysis. In exercises 35 and 36, the letters A, B, and C are marked on the horizontal axis. Describe the shape of the data, then determine which is the mean, which is the median, and which is the mode. Justify your answer. So, as we look at this data, this is a skewed left graph. The median would be the number that's in the middle, and so that would be B. The reason it's B is because you have all that data to the left, that's going to add up to about the same amount of data on the right. B is going to be, in general, your middle number. The mode would be C because that's the highest bar, and the mean would be A. We're going to have to add all that lower data up, and it's going to average out with the higher data. In general, for those ones, it's pretty close to, it's going to be that way most every time. Now, they do set it up so that it could look different, but especially when it's skewed like that, your middle one's going to be the median. The highest bar is obviously going to be the mode, and then the lowest is going to be the mean. When it's skewed right, it's going to be the opposite. Your median will still be the middle, which your highest bar is going to be the mode, and your mean would be the one to the furthest to the right. But anyhow, number 38. Without performing any calculations, which measure of central tendency best represents the graphed data? So for this one, number 38, I would say it is either the median or the mean. The reason it would be that is because your graph is symmetrical. When it's symmetrical like that, it's usually going to be the mean. Number 40, which one would best represent? I would say this one is the mode. Because your mode is going to be your two highest. And because it's your two highest, it would be a bimodal one. And it would kind of forget this outlier. If you did a median, it's probably going to fall in this category, which doesn't show that it's necessarily average. By the way, number 38, mode could have worked too. So it could have been mean, median, or mode. Any one of those would have worked because of how symmetrical it is. Number 42, the scores and their percent of the final grade for an archaeological student is shown below. What is the student's mean score? Okay, so this is an example of a weighted mean. So whenever you find the weighted mean, it is 95 times the percentage is a decimal, 0.1, plus 100 times 0.1, plus 89 times 0.3, plus 100 times 0.1, plus finally 92 times 0.4. Let's take all that and divide it by 100. And I'll find your weighted mean. Let's do that calculation real quick. 9.5 plus 10 plus 89 times 0.3 plus 10 plus 92 times 0.4 gives you 93. So if we need to show it as a percentage, then it would be 0.93, which is why we divide by 100. It just says what's the student's mean score, so you wouldn't even have to divide by 100 because you wouldn't need to show that the percentage is a decimal. So it would just be 93 outright. Number 44, for the month of May, a checking account has a balance of $759 for 15 days, $19.85 for 5 days, $14.10 for 5 days, and $3.48 for 6 days. What is the account's mean daily balance for May? So, in order to do this, you're going to do 759 times 15 plus 1985 times 5 plus 1410 times 5 plus 348 times 6, and then we divide by the number of days. So 15 and 5 is 20, that's 25 and 31. Guess we would have known it was 31 because May has 31 days, but whatever. Don't judge me. And so you get a average balance of 1055.65. All right. Moving onward. Number 46. The mean scores for students in a statistic course by major are shown below. What is the mean score for the class? So you have 9 engineering majors at 85. So we'll give you 9 times 85 plus 5 times 90. Okay, math majors. Plus 13 times 81. And then you divide that by the number of people in the class. 9 plus 5, which is 14 plus 13, so 27. It gives you an average score of 84 in the class. All right, number 48 says in exercise 45, one of the students' B grades get changed to an A. What is the student's new mean grade point average? That would mean that we had to do 45, so we can skip that question because I didn't make you do 45 yet. Number 50 says find the approximate the mean of the frequency distribution. Easiest way to do this one is to figure out what your midpoint is for each of the categories. So 27 plus 22 divided by 2. So give you 24.5 for your midpoint. So you do 16 times 24.5 plus then your midpoint of the next one. It's going to be 30.5. Multiply that by 2. Then you do 34 plus 39 divided by 2. Gives you 36.5. So you do 2 times 36.5 plus 3 times 42.5 Then lastly, you do 1 times 48.5. Okay, so we're going to add those all together. 16 times 24.5 plus 30.5 times 2 plus 2 times 36.5 plus 3 times 42.5 plus 1 times 48.5 gives you 702. Then you divide by the frequency, which would be 1824. And you get 29.25. All right, number 52. Ages of the residents, blah, blah, blah. I leave myself enough room to do work on here. Let's see. That's better. All right, so we can figure out what the middle age is. Just do 9 plus 0 divided by 2. So give you 4.5 and 14.5 and 24.5, 34.5, 44.5, so on and so on. It's all going to be whatever 84.5, all that, right? Then you take that and multiply it by the frequency. This would be 30 times 4.5 plus 28. I don't want to put a parenthesis there. Plus 28 times 14.5 plus 17 times 24.5 plus 22 times 34.5 plus 23 times 44.5 plus, I wish I knew a different way to do this, 46 times 54.5. This is just a hassle. Plus 37. How do I keep doing that? Times 64.5 plus 18 times 74.5 plus 4 times 84.5. All right, let's add all those together. Thirty times 4.5 plus 'in the end, this gives us 9312.5. Then we take that and divide it by the number of numbers or the frequencies. And that number is 225. Could have at least gave us the number of resonance. It's 9312.5 divided by 225. And that gives you 41.4. So it's fun. All right, on to number 54. So we're identifying the shape of the distribution, construct a frequency distribution and a frequency histogram for the data set. Okay, number of classes is 6. There's so many questions left. Number of classes is 6. We're going to take and put it in order. Our highest number is 14. Our lowest number is 3. So you do 14 minus 3 divided by 6. It gives you 11 divided by 6. And then you round up. So it's going to give you about 2 per class. So your classes are going to be 6 to 7, 8 to 9, 10 to 11, 12 to 13, 14 to 15. This doesn't make any sense. Hold on a second here. 14 and 3 is 11 divided by 6. Oh, completely forgot 4 to 5, or 3 to 4. I don't know why I started with 6 to 7. Completely screwed it up. Start with 3 to 4, then 5 to 6, 7 to 8. 9 to 10, 11 to 12, 13 to 14. That's a lot better. Then your frequency is how many fall within each category. So from 3 to 4 is 1, 2, 3. From 5 to 6 is 1, 2, 3, 4, 5, 6, 7, 8. From 7 to 8 is 1, 2, 3. 9 to 10 is 1, 2. 11 to 12 is 2. And 13 to 14 is 1. Then we make a frequency distribution. So it's like that. We'll start at 3.5 and 5.5, 7.5, and 9.5, and 11.5, and then 13.5. So this is 3, goes up to 3, and over, down. This one is 8, goes all the way up to 8. It's a great histogram. Then 3 again, then 2, then 2, then 1. I don't even remember what I was asking now. Describe the shape of the histogram as symmetric, uniform, negatively skewed, or positively skewed. This would be a positively skewed, or I would call it a skew right. All right. Let's call it a day. So tomorrow we will go over the odd questions, finish these even ones out, and we'll be good to go. All right, guys. Thanks for paying attention. Especially you, Brooklyn. I know you paid attention a lot.